A stunt double for this film. We always need a stunt double for the Milky Way because this is our view of the Milky Way. So this is a drawing of the Milky Way. We have lots of things like this, but it doesn't really tell us what we need to. And so people took this and said, oh, you know, M83 looks sort of like that. We can use M83 as a stunt double. And so our friends at NCSA used it as a stunt double in the PBS NOVA program, Runaway Universe. They said this was the Milky Way. It actually was based on M83. Well, we took a look at Andromeda and we said, you know, trying to flatten that out and spin that out and use that in full 3D, not going to be so good. So what we did actually is we took another stunt double, okay, and we took M81 and distorted it, okay. So this is what the Hubble image looked like. We had it at high resolution. We distorted it in order to match what Andromeda looks like. And if you look at it, you can see the feature for feature. It does a rough approximation of it. We didn't do this just in visible light. We also did it in infrared with a Spitzer image and in ultraviolet with a Galax. Passed that along to NCSA so they could model Andromeda for the film. So when you see Andromeda in the film, you should know that it really isn't Andromeda, okay? It's M81. Shh, don't tell anybody. All right. We also had to float galaxies for that sequence where we're going from the Milky Way to the Virgo cluster. These galaxies all have to be floated so they can float in 3D, get rid of all the stars, get rid of all the things around them. And then there were also some template galaxies that they wanted to use. And you'll see, actually, whenever I see NGC 1300, it catches my eye. And it appears at least 2 or 3 times in the film. And it bothers me because its bar always catches my eye. All right. That leads me to the sequence of billboards for galaxies in what I call 2.5D, okay? Not full 3D, 2.5D. This is the Great Observatory's Origins Deep survey that we used in our IMAX short film. Inside it is also the Hubble Ultra Deep Field. The Ultra Deep Field is the longest visual light exposure ever taken. 10,000 galaxies in here, and we wanted to fly through that in 3D in the IMAX film. Okay, to do that, we of course need every single one of those galaxies on its own little cutout. Okay, we do that with a piece of software called Source Extractor that I'll discuss later in my talk. For now, just assume that magically we get these pictures of every single one of these galaxies. Well, of course, they aren't solo; they are next to each other. So the cutouts will, of course, have other galaxies in it. Fortunately, Source Extractor gives you what you call a segmentation map, and it identifies which pixels are associated with which galaxy, or which source. And so all of the colored ones are not associated with galaxy 16999, only the white ones are. And so one can go into Photoshop, or I actually wrote some C code to do this, to go in and keep only those pixels, and then do a feather away from that so that it smooths out to black and then would be transparent around it, so you get a galaxy that will float in 3D. We then have to clean them because this is astronomy data. It has noise at the edges. That's not so hard for these big galaxies, but you get down to your smaller galaxies, you can really start to see the noise around it. You get to your tiny galaxies. Yes, this is a real galaxy. The pixel, the signal to noise is very low. We designed 3 different algorithms to go back and clean all the galaxies that got close to the camera in our IMAX film, and then so that they would float. Here's our data pipeline. We got the images, we got the segmentation maps, we got the data about the images, and the data about the redshifts, which is the distance. Think of it as distance. We pull them together to get the galaxy images. I'm using Perl, IRAF, C code. I have Perl code, which is my favorite glue language for things. So we have the galaxy images and galaxy data. Pull those together. We do the 3D modeling in Perl script to output some MEL code, which goes into the 3D modeling program Maya. If you've never heard of MEL, this is what it looks like. Create node polyplane, and then the plane shape, and then attach the Lambert, where's the Lambert shading engine, and the material, and the file that associates, and so on and everything. That's all the commands that go into Maya, and then boom, you have your 16,000 galaxies in Maya. About 10,000 galaxies in the Goods field, and about 5,000 or 6,000 in the Hubble Ultra Deep field. Going up close, you can see that these are just little rectangles floating in 3D space. I did not texture map them for you because it takes a long time to run interactively with 16,000 texture maps. Turning sideways, you can see here's where Hubble sits, here's where the field sits, and you can see the concentration of galaxies. And this we can fly through in 3D. And I have to do my microphones for this next piece here. Hold on a sec. And I'll show you what we did for the IMAX short film, the effect that you get from this.
take the sound coming out
Yeah. They turned my microphone down. My microphone should be.
These galaxies are somewhat disheveled. Their mature structure is still developing. When the universe was young, newly formed galactic disks were ablaze with star formation. Beyond this point, clumps of stars that are beginning to form galaxies.
All right, well, the sound worked better when we tried it out before the talk. I apologize. But you can see what you can get. It's a relatively powerful presentation, and it really is just 2.5D, 2D galaxies flying past you.